Good afternoon. I am Mr. H. Thank you for joining me. We're looking slightly at an out of ordinary topic, evaluating graphs, especially linear graphs. You know linear graphs or linear equations are y equals mx plus b, but more than anything you have to be able to understand what the components mean and sometimes how to look at other functions which can be converted into this. Y equals mx plus b, you have a variable here y, you have a variable here x. X is the independent, y is the dependent variable. This right over here represents your rate. This here represents your y-intercept. But what does that all mean in terms of a graph? If you have a specific equation which looks like this and our curve looks like that, right here represents our y-intercept, you could say this is 0, comma b. The incline or the slope of this line will be your rate. It will tell you exactly at what rate that this line inclines. You know, how steep is this? And the rate usually has a practical value in terms of economics or scientific models, all of that. Rate will tell you exactly the inclination of your line, which will have some practical value attached to it. Of course, we're not talking about experiments here, but we're talking about what these components represent. You can very well have a situation of the opposite nature where you have something which is aimed downwards. Here, of course, this here is your 0, comma b, and your this specific rate over here would be negative. Here the rate is positive because it's aiming upwards. In that instance it's negative because it's aiming downwards. You always evaluate the rate or the slope of a line from left to right. Is the line going down or is it going up? As you go towards the right, if your line dips, it's a negative slope. If your line goes up as you're going from left to right, then you have a positive slope. The rate of change is something very important, and for linear equations, remember this. For linear equations, the rate of change, ROC, is always constant. What does that constant mean? It means it's always uniform or always having a single value which does not change. You have a straight line, there's no curve in this line, therefore whatever the rate of change is over that entire independent variables, the rate of change is the same. If you have a certain value over here and you look at the rate of change and a certain value here and the rate of change at both sides or both points are the same, or the slope is the same across that entire line. You have to contrast that very much so with a line which is not linear. If your line which is not linear, the slope here is different, the slope here is different, the rate here is different, the rate there is different. Linear lines have the same constant rate of change across their entire length. Consider this equation right over here. It could be anything, but we have something which looks like this. Some of you will probably see this to be some sort of exponential model. You can say it's like a continuous compound interest. It could be related to a exponential population growth. But look what happens when you take the AO on the other side. You have AT over AO is equal to e to the RT. Now look what happens when you get rid of that exponent. You have natural log of AT over AO is equal to RT ln E. ln E is 1. You basically have natural log of AT over AO is equal to RT, and you use the laws of logarithms. You can have natural log AT minus natural log of AO. AT and AO are variables, is equal to RT. Then natural log AT is equal to a natural log of AO plus RT. And now we've converted something which was an exponential equation into a linear. Y is equal to mx plus b. Here's my b, here's my mx, here's my y component. You see how we've used laws of logarithms, converted an exponential into that linear equation. If you're looking here at this specific equation, it would very well be an equation which would look something like that. An exponential graph. You're looking at this, it's something which would represent, you have a positive slope here, right? Positive RT. A line which would look something like that. You could extend it down here, but the fact that we have natural log, you don't do natural log of negative numbers, right? So you might as well get rid of that line in the negative zone. In terms of the graph, it would very well be like that. My natural log ln AO, my y-intercept is this. My rate would be very well the slope of this line. Whatever that slope is, that's your rate. And that right there is how you can convert one form into another. So linear equations can very well be derived from non-linear equations by means of laws and procedures. Let's look at this question, and we'll use graph and we'll use algebra to look at this. It's still an evaluating a graph type of question. Pens, you know, like the writing pen costs 5 cents, $0.05 per unit to make. How much does it cost to make 1,000 pens? It's a fairly easy question. But what are we looking at over here? We're looking at something which is a rate. The rate is this, because you're seeing something which has more than one unit. You have a price and you have a quantity. You have something which is a price over quantity, and that right there would be representative of your slope. Right? It costs 5 cents per unit to make. And what is the cost to manufacture 1000 pens? Well, how would you look at that? Y is equal to mx plus b. We know the rate over here is this, the slope 0.05x plus b, and y is equal to that. We need to know what b is. How can you figure out what b is? Well, think about common sense over here and logic. A graph of something like this, 0.05 is not a large number. It's a very shallow slope. It's still upwards, but it's very shallow, and you're not going to have negative money. You'll only have positive money. You can have quantity over here and you can have price over here, and you'll have a line which will go across like this. It's not a steep line, but it's a very shallow line because this number is very small. It's still positive, but it's small, so it's a shallow slope. But what is a very important point here is this. If you make 0 pens, it costs you $0, and that can very well give you your B value. If you're not making any pens, you're not using up any money. So therefore you have a good value here, 0, 0, which is a good intercept. This y-intercept is actually 0, 0, which is just a 0, which is meaningless to write, and your equation becomes y equals 0.05x. Hence you have a y-intercept here at the origin, and you have this line y is equal to 0.05x. The rate or the slope is 0.05. Now how do you find 1000 pens, the cost of that? All of this is equal to f of x. So you're really doing f of 1000 is equal to 0.05 of 1000, multiplying it, and you multiply 0.05 and 1000. You can just do 3 decimal places, 1, 2, 3, and it'll cost you $50. And that'll be your answer. The pens cost 5 cents per unit. To make 1000 pens, it costs you $50, and we've done it by means of evaluating a graph, and we've done it by means of linear. Now let's look at a second question, but we'll adjust this question a little bit. Our second question is this. We've just modified it by adding this. The pen machine costs $25 to keep running. You have a certain factory which makes pens, and of course everything here is hypothetical. The scenarios I'm presenting might not even be real life or sustainable scenarios, but we're just utilizing these questions here just to understand or develop that basic understanding. The pen machine which makes the pens, it requires $25 to keep running no matter what. You can't turn the machine off. Whether you're making pens or not, you're still running the machine, and it costs $25 to keep it running. It's like an operating cost. Remember, again, we're still looking at y is equal to mx plus b. We still have a rate. The mx component, which is your rate, is still exactly $0.05 per unit or per pen, and we have to still determine the cost of 1000. The only difference here is now this right here tells you that it's no matter what, you still have something which will cost you $25, and that right there will be this. Your y-intercept here will be 0, 25, because this is something which you have to pay no matter what. You have a graph which will look something like this. Here is 0, 0, but here this is my money line, this right here is my quantity line, the number of pens, and you have a curve which will look like this. It'll still be a relatively flat. I made it too steep because 0.05 is a very shallow slope. It'll still be a curve which will look something like this, but it'll start here from 0, 25. Now all of a sudden your equation is y is equal to 0.05x, which is your slope, plus 25, because that's your base amount you have to pay no matter what. So what's the cost here now to do 1000? You do 0.05 times 1000 plus this $25 for the machine, which you have to pay no matter what. And here your answer will be 50 plus 25, right? This is $50 plus 25, and here it will cost you $75. Before it was $50, and we didn't have this constant or fixed price. Here we have it, and we have to pay a little bit more to make those 1000 pens, and it's $75. So keep in mind, money is usually on this side, the quantity is usually on this side, the x-axis, or your time is on the x-axis. This right here is your y-intercept. The incline of your line is your rate. The rate is your slope, right? It's the same as your slope. And this is what you want to look at. This right here is what you're solving for, and this right here is your y-intercept. Sometimes the y-intercept is 0, 0, sometimes y-intercept is actually a value, and you start from there. And your graphs will usually point upwards and or downwards based on loss or whatever, but you'll never go here in the negative side, because in the real life situations you don't have negative money, you don't have negative pens, you don't have negative time, but everything is always from 0 onwards. And that will be it for this video. Thank you for watching. Have a nice day.